So this lecture is on solving quadratic equations by completing the square. But before we get into completing the square, there is a simple property called the square root property, which forms the basis for completing the square. The idea is quite simple. If we have an equation, we try to write one side, typically the left-hand side, as a perfect square, and the right-hand side as a number, and we simply take the square root on both sides to find the solution to the equation. And this only works for quadratic equations, and quadratic equations are equations of the form ax squared plus bx plus c equals 0. So that would be a quadratic equation. So here is the first equation, which is x squared equals 49. So if you look at the right-hand side is a perfect square, and the left-hand side is just a number. It doesn't have to be a perfect square, it just has to be a number. So what we do is take the square root on both sides, which is why we call it the square root property. So we would simply have square root of x squared equals square root of 49. Square root of x squared is simply x. Square root of 49 is plus or minus 7. And that is the solution. And it is that easy because we have the left-hand side to be a perfect squared, and the right-hand side is simply a number. In the next example, we have 2x squared equals 4. So we divide by 2 on both sides to simplify first. So x squared would equal 4 over 2. So x squared would simply be equal to 2. Notice the right-hand side doesn't have to be a perfect squared. All we're doing is taking the square root on both sides. So x would simply be equal to plus or minus square root of 2. So no matter how complicated the left-hand side is, as long as it is a perfect square, we can use the square root property to find the solution. In the next equation, you could see that y minus 3 squared is a perfect square. So if I take the square root on both sides, I would have square root of y minus 3 squared equals square root of 4. So we all know that the root and the square will get cancelled, and square root of 4 is plus or minus 2. So y minus 3 would equal plus or minus 2. Move the 3 to the other side. Y would equal to 3 plus or minus 2. So the two solutions are y equals 3 plus 2 and 3 minus 2. We know 3 plus 2 is 5, 3 minus 2 is 1. So those are the two solutions for the equation. The next example is also pretty straightforward. In the sense we have a perfect square on the left-hand side, which is x plus 2 whole squared. So we have x plus 2 squared equals 25. Take the square root on both sides. The root and the square would get cancelled. So we would simply have x plus 2 equals square root of 25, which is plus or minus 5. So x would equal to negative 2 plus or minus 5. So x would equal to negative 2 plus 5 and negative 2 minus 5. Negative 2 plus 5 is positive 3. Negative 2 minus 5 is negative 7. And those are the two solutions. So here is a slightly more complicated example, but still you can see the left-hand side is a perfect square, so we could simply use the square root property to find the solution. So take the square root on both sides. The root and the square would go away. And before that, we have to take the square root on that side also. And now we have 3x minus 17 equals square root of 28. Now I could write square root of 28 in terms of a perfect square, which is 4. 4 times 7 is 28. So that would equal to square root of 4 times square root of 7. So square root of 4 is plus or minus 2. And we have square root of 7. So 3x minus 17 is equal to plus or minus 2 root 7. Add 17 to both sides. We would have 3x equal to 17 plus or minus 2 square root of 7. Divide by 3 on both sides. 17 plus or minus 2 root 7 divided by 3. Since we have a common denominator, we can write it as 17 over 3 plus or minus 2 root 7 over 3. So the two solutions are x is equal to 17 over 3 plus 2 root 7 over 3 and 17 minus 2 root 7 over 3. So here is another method called completing the square. So we want to solve a quadratic equation like the ones we had before, where we had a perfect square on the left hand side, and all we have to do is take the square root. But here is a case where we don't have a perfect square on the left hand side. So the first step is to convert the expression on the left hand side to a perfect square. And the process of achieving that is called completing the square. But before we get to that, let's move the 8 to the right hand side, left hand side. And that is a quadratic equation. And here A is 1. That's A. B is 6. C is 8. And now, how do we complete the square? So the variable is y. I'm going to put a box here. And I'm going to put c minus a box and squared equal to 0. What goes in the box? b over 2 goes in both boxes. So we have 1, b is 6, 6 over 2 squared, plus c is 8, minus 6 over 2 squared equals 0, which would give us y plus 6 over 2 squared, plus 8 minus 3 over 2, 6 over 2 is 3, squared equals 0. So y plus 3 squared plus 8 minus 9 is minus 1 equals 0, which would imply y plus 3 squared is equal to 1. Notice how the left-hand side now is a perfect square. So we can use the square root property to solve this equation. So take the square root on both sides. And square root of 1 is plus or minus 1. So the root and the square would go away. So y plus 3 would equal to plus or minus 1, which would imply y plus 3 is equal to, well, y is equal to, move the 3 to the other side, minus 3 plus or minus 1, which would imply y is equal to minus 3 plus 1 minus 3 minus 1. Negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4. And those are the two solutions. Keep in mind, this process of using the boxes here and filling in those boxes can only work if the leading coefficient, which is right there, is 1. In other words, the value of a must be 1. So here we have a quadratic equation. So a is 1, b is 1, c is negative 7. So we can use the quadratic or completing the square without any issues. So y is the variable. So b over 2 has to go inside the box. So y plus b is 1. So 1 over 2 squared. C is negative 7 minus 1 over 2 squared equals 0. Y plus 1 over 2 squared minus 7. If we squared negative 1/2, we have negative 1/4. And I want to combine negative 7 and negative 1 over 4, which means I'd like to have a common denominator. The common denominator is 4, so I'm going to multiply and divide negative 7 by 4. So I would have negative 7 times 4 divided by 4 minus 1 over 4 equals 0. So y plus 1 over 2 squared minus 28 over 4 minus 1 over 4 would equal 0. And y plus 1 over 2 squared, common denominator, is 4, so we have negative 29 over 4 equals 0, which would imply y plus 1 over 2 squared, move the negative 29 over 4 to the other side, we have 29 over 4. Now the left-hand side is a perfect square, so all we have to do is take the square root on both sides. Square root of 1 plus 1 over 2 squared equals square root of 29 over 4. The root and the square will get cancelled. So we would have y plus 1 over 2 equals square root of 29 divided by square root of 4. So y plus 1 over 2, square root of 29 is not a perfect square, and you can't use any other number to write it as a perfect square. So that would remain as is. Square root of 4 is 2, so I have plus or minus square root of 29 over 2. Move that 1/2 to the other side. We have 1, or y equals negative 1 over 2, plus or minus square root of 29 over 2. So the two solutions are negative 1 over 2 plus square root of 29 over 2 and negative 1 over 2 minus square root of 29 over 2. So here is our final example on completing the square. Notice here a is 2, b is 14, and c is negative 1. And I mentioned that completing the square works nicely when in solving quadratic equations if a is 1. But in this problem, a is not 1. So what do? We have to make it 1. How can we make it 1? You take the equation and you divide by the value of a on both sides. And you will see that 2 is a common denominator to every single term in the numerator. So I can split it up and write it as 2x squared over 2 plus 14x over 2 minus 1 over 2. And 0 over 2 is simply 0. So the 2's would go away. 2 and 14 would get cancelled. So I have x squared plus 7x minus 1 over 2 equals 0. Now the equation turned into the original equation, turned into this equation where we will have a is 1, b is 7, and c is negative 1 over 2. So I can use the process of completing the square now. So I have x plus the box plus c minus the box squared equals 0. And what goes in the box? It is b over 2. So we will have x plus b is 7, so 7 over 2 squared. C is negative 1 over 2 minus 7 over 2 squared equals 0. So x plus 7 over 2 squared minus 1 over 2 minus 49 over 4 would equal 0. And we would want to combine negative 1/2 to negative, or combine with negative 49 over 4. And we could do that if we have a common denominator. So I'm going to multiply and divide negative 1/2 by 2. Multiplying and dividing by 2. So I will have x plus 7 over 2 squared minus 2 over 4 minus 49 over 4 would equal 0. Since we have a common denominator, we can combine the numerators. Negative 2, negative 49 is negative 51 over 4 equals 0. Move that negative 51 over 4 to the other side. We have x plus 7 over 2 squared equals 51 over 4. Now, You can see that the left-hand side is a perfect square and the right-hand side is simply a number, so we can use the square root property and take the square root on both sides. So square root of x plus 7 over 2 squared would equal to square root of 51 over 4. Of course, the root and the square would get cancelled. We'll have x plus 7 over 2 to equal the square root of 51 over 4, which is square root of 51 divided by square root of 4, and that would be square root of 51 over 2. And of course we'd have a plus or minus. And move that 7 over 2 to the other side, so we have minus 7 over 2 plus or minus square root of 51 over 2. So the two solutions are minus 7 over 2 plus square root of 51 over 2 and minus 7 over 2 minus square root of 51 over 2. And that is the process called completing the square.